Welcome back, Geometry Scholars. Today's lesson is on properties of and conditions for parallelograms. Our essential question is how can you determine the similarities and differences between various quadrilaterals? And by the end of the lesson, I hope that you can define and identify parallelograms. Don't forget, as you are watching this lesson, if you have any questions, to write them on the margins. Let's get started. A quadrilateral is a polygon with 4 sides. And I hate that when that happens. There we go. 4 sides. The sum of the interior angles of any quadrilateral is 360 degrees. So it doesn't matter what it looks like. If it has only 4 sides, it's a quadrilateral. And if you add up those interior angles, they're going to add up to 360. Like a triangle with 3 sides adds up to 180. A quadrilateral with 4 sides adds up to 360. The prefix of quadrilateral is quad. Quad means 4, so quadrilateral, 4 sides. But there's a specific type of quadrilateral that we're going to be dealing with today, and that's a parallelogram. A parallelogram is a quadrilateral that has 2 pairs of parallel sides. Doesn't mean they have to be congruent, they could be, but they have to be parallel to each other. So let's look at the properties of parallelograms. If a quadrilateral is a parallelogram, then all of these things happen. If a quadrilateral is a parallelogram, then both pairs of opposite sides are parallel. So DC is parallel to AB, notice the arrow mark there, and AD is parallel to BC. Both pairs of opposite sides are parallel. Therefore, the same side interior angles are supplementary. What does the word supplementary mean? They add up to 180. So that means angle A plus angle B equal 180. So A and B, or angle B and angle C have to equal 180. And if you add them up, and so on, angle C plus angle D equal 180, or angle D plus angle A, the same side interior angles, also called the consecutive angles because they're next to each other. The next theorem is also true. If a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So BC, AD, they're congruent to each other. BA, CD are congruent to each other. So if a quadrilateral has both pairs of opposite sides congruent, then it is, by definition, a parallelogram. Third one, both pairs of opposite angles are congruent. So C is congruent to A and B is congruent to D. Since this quadrilateral has both pairs of opposite angles congruent, then it is a parallelogram. Next one, both diagonals bisect each other. Now this does not mean that AC is equal to BD. That's not what this means when it says that bisect each other. It means that they cut each other in half. So when BD intersected AC, BD got cut in half, and AC is now in 2 equal parts. Okay? That's what it means by they bisect each other, not that they're congruent to each other. So if you see a shape where the diagonals bisect each other, then that means it is a parallelogram. Last one. It's also a parallelogram if at least one pair of opposite sides are congruent and parallel. So notice here the only marks are the fact that BC is congruent to AD and also that BC is parallel to AD. So since one pair is congruent and parallel, by nature, by definition, it is also a parallelogram. So if you're looking at a shape and either any of these 5 things are true, where both pairs of opposite sides are parallel, or both pairs of opposite sides are congruent, or both pairs of opposite angles are congruent, or both diagonals bisect each other, or at least one pair of opposite sides are congruent and parallel, if that is true, if any of those, just one of them is true, then you have a parallelogram. Example 1. Find the values of x, y, and z. So let's look first at x. Is this a parallelogram? Well, yes it is, because this side is parallel to that side, and this side is parallel to that side. So since I know it's parallel, since I know it's a parallelogram, what can I assume about that side and that side. They are congruent to each other. So 2x minus 3 equals 37. Okay, so now that I know it is a parallelogram, the opposite sides are equal to each other. So 2x minus 3 equals 37. 2x equals 40, because I added 3 to both sides. X equals 20. Okay, let's look at my next one, y. Okay, since it's a parallelogram, looking back at your conditions, you know that opposite angles are congruent. So if L is 123, the angle across from it is N. So y is also 123 degrees. Okay? And then if it's a parallelogram, that means that the same side interior angles or the consecutive angles are supplementary. What does supplementary mean? It means they add up to 180. So z plus 123 equals 180. Well, if I subtract 123 from both sides, I will know that z equals 57 degrees. So once I knew this was a parallelogram, I knew that the sides were equal to each other, that the opposite angles were equal to each other, that the same side angles were supplementary. And that's the information I used to solve this problem. Example 2. For what value of x is quadrilateral PQRS a parallelogram? So looking at the shape, we do not know anything about the angles. We don't know anything about the sides. What they did give us was the diagonals. So I see that QS was bisected by PR. Okay, so QS was cut into 2 equal pieces. I see that QT is now equal to ST. What I do not know is if QS bisected PR. Did QS bisect PR? Did it cut it in half? Is PT congruent to RT? It doesn't show that it is. But in order for this to be a quadrilateral, in order for this quadrilateral to be a parallelogram, then yes, this needs to have been cut in half. So the only way that this is a parallelogram is if the diagonal was cut in half, so cut into 2 equal pieces, which means that 5x equals 2x plus 9. So we're finding the value of x that makes this true. So this becomes 3x equals 9, because I subtracted 2 from both sides. X equals 3. So if x equals 3, then I can plug 3 in here. What's 5 times 3? 5 times 3 is 15. What's 2 times 3? 6. 6 plus 9 is 15. So if x equals 3, then the two sides are equal to each other, which means that the diagonals have bisected each other, and that, yes, this is a parallelogram. Number 3. Can you prove that the quadrilateral is a parallelogram based on the information given, and explain what theorem you would use? Okay, so the first one says A. Can I tell this is a parallelogram by this? The answer would be yes. And how do I know? Both pairs of opposite sides are congruent. And I just put the symbol for congruent. Both pairs of opposite sides are congruent. I want you to try B and C on your own. Look back at the properties of parallelograms on your front side of your notes and see if you can figure out if B and C are parallelograms. So please pause the video, do B and C, and then resume. Okay, letter B is yes, because the diagonals bisect each other. They cut each other in half. And then letter C is no. There's not enough information. All we know there is that there's one pair of opposite angles that are congruent. We would have to have both pairs. Okay, so let's go on to the next problem. Determine whether, or decide whether you are given enough information to determine that the quadrilateral is a parallelogram. So we're going to say yes or no. Is this enough information? If both opposite sides are parallel. So both pairs of opposite sides, if they're parallel, is that enough? Well, yes it is. That's actually the definition of a parallelogram. Both pairs of opposite sides are parallel. If the diagonals are congruent to each other, is that enough? No. Okay, because diagonals don't necessarily have to be congruent to each other. Looking back at this picture, the diagonals are congruent to each other. The diagonals were cut in half. So the two halves, or the one half is equal to the other half. But this red diagonal is not necessarily the same size as the green diagonal, okay? So just because the diagonals are congruent does not mean that it's a parallelogram. If one pair of opposite sides are congruent to the other pair of opposite sides, one pair of opposite sides are congruent and the other pair of opposite sides are parallel. Is that enough information? And the answer here is no. It has to be one pair that's opposite and congruent. So if it said the same pair of opposite sides is congruent and parallel, then yes. But since it says one pair is congruent and one pair is parallel, no. And I'll draw that out. I said that this side was congruent to that side, but this side was parallel to that side. Is that enough? No, that's not enough. And then letter D. The consecutive angles are supplementary. Consecutive angles, the same meaning as same side angles. And yes, sorry about that, guys, intercom announcement. So again, consecutive angles means same side interior angles, and if they are supplementary, if all of the pairs of them are supplementary, then yes, it is a parallelogram as well. Okay, so pretty easy material. There are some things you have to memorize. You have to get very familiar with looking at shapes and trying to figure out what is a shape telling me, what else do I need to know, but it's not hard if you work hard to commit it to memory. Have a great day. I'll see you guys next class.